Hello, my dear students. In this video, we will be talking with mathematical system in geometry. So at the end of this video, you are expected to attain this learning competency. Describe a mathematical system. These are the learning objectives. Identify the composition of the geometric system. Describe or define each component of the system and its parts, and illustrate each part of each component. Okay, let's explore first. Answer the following questions. Have you watched the stars at night? Do you know the composition of your body? Do you know what our society is composed of? Do you know what makes up a certain object or situation? Now, have you noticed something common to these things? The stars at night, the composition of your body, the composition of our society, a certain object or situation. Yes, you're right. All of them have something in common, and that is a system. When we say system, it is composed of several parts with specific purposes, just like in the field of geometry, where concepts are organized logically. So like those different things, we also have what we call mathematical system in geometry, which is composed of four. Now let us unleash each component of the mathematical system in geometry. So what you're going to do is to rearrange the given jumbled letters to reveal the different components. First, I will give you 10 seconds. Very good. It's undefined terms. How about this one? You're right. It's defined terms. How about this one? Excellent. This is theorems. How about this last one? Okay, of course we have postulates. So these are the four components of the mathematical system in geometry. But before we discuss each of these four components, let us first focus on geometry. It is derived from the two Greek words geo and metron. Geo means earth and metron means measurement. So it is the measurement of different things on earth. By definition, it deals with the sizes, shapes, positions, angles, and dimensions of things. Now let's proceed to the mathematical system in geometry, which was developed by Euclid. So again, it is composed of the undefined terms, defined terms, postulates, and theorems. Let's start with the different undefined terms. When we say undefined terms, these are terms that do not require a formal definition. So from the name itself, undefined, un means not defined. It does not have exact definition, but they can be described. Okay, what can you see here? Of course, aside from the presentation design. Okay, in here we have a small dot. So the first undefined term in geometry is a point. When we say point, it is represented by a dot. Take note, it has no dimension. It does not have a length, nor a width, nor a height, or nor a thickness. But a dot can be a larger one or a smaller one. And in naming a point, we use capital letters. One capital letter for each point. So say for example, we have here point M, point A, and point T. Next, we have here a straight line with arrowheads on both sides. What do we call this? Very good. It's a line. It is described as straight. It is described as a straight figure extending infinitely in both directions. So the arrowheads imply extension to both sides. To name a line, we use any 2 points on the line. So like this one, we have point A and point B. So we can name this line as line AB. But aside from using two capital letters to name a line, you can also use a small letter. So say for example, line M or line N, as long as that one single letter is a small letter. Another one, we have this figure. What do you think is it? Very good. It's a plane. It's a two-dimensional figure. It has a length and width but no thickness. In naming a plane, we can use three or more points that are found on the plane. So say for example, we have these point A, point B, and point C that are on the plane. Then we can name this one as plane ABC. But aside from using three or more points that are found on the plane, we can also name it using one small letter, like this. So this can also be named as plane M. So those are the three undefined terms in geometry: the point, the line, and the plane. Let's now proceed to the next component, which is the defined terms. We will be having terms that have a formal definition and can be defined using other geometrical terms. We have here a line. From that line, we took apart, forming another straight line but with no arrowheads on both sides. This is called a segment. It is a subset of a line with two endpoints. Although it's a type of a line, take note that the difference is that on both sides for a segment, we now have endpoints. For line, we have two arrowheads. In naming a segment, like naming a line, we use 2 points that are found on the line. But for a segment, we must use the two endpoints. So like this one, we have points A and B as the endpoints, so we can name it segment AB. In symbols, we have this one, AB, and a horizontal bar on top of those two capital letters. Next, we have here a ray, and then another ray. If we combine those two rays such that their endpoints are now common or the same, what do we call this one? Very good. It's an angle. With definition, it's a figure formed by two rays with a common endpoint called vertex. Take note that for a ray, again, it's a subset of a line, but on one end, we have an endpoint, and on the other side, we have an arrowhead. So it can be extended only on one side of the line. So if we have two rays and those two rays meet at the common endpoint, then it's an angle. And that common endpoint is called the vertex. So in this figure, let's name the vertex as point A. Then we have point B and point C on the rays. In naming an angle, we can use the three letters or 3 points that are found on the angle, but make sure that the vertex should be at the center or at the middle. So we can name this one as angle CAB or angle BAC, as long as the vertex is at the center. Aside from naming it using three letters, if there is only one angle formed using that vertex, then we can name it using the vertex. So we can also name it as angle A. Take note, if there are two or more angles formed using that vertex, then you cannot name it using the vertex because there will be more than one angle pertaining to that angle if you use the vertex. But aside from letters, we can also use numbers to name an angle. Those numbers are seen inside the angle, specifically close to the vertex. So we can also name this as angle 3. There are three ways in naming an angle. Next, we have here two lines. What do you think is the relationship of these two lines? Okay, they are parallel lines. By definition, these are lines on a plane that do not intersect no matter how far they are extended. So even if we extend these two parallel lines on either side or both sides, they will never meet. So if we name one line as line M and the other line as line N, then we say that line M is parallel to line N. In symbols, we have M, and then in symbols, we have this one. So for parallel lines, we use this symbol, two vertical lines. So we have M is parallel to N. Next, we have here a vertical line intersected by a horizontal line forming right angles. If you can see a square or a rectangle formed on the vertex of an angle, then that implies that the given angle is a right angle. So what do you think now is the relationship of those two intersecting lines? Very good. They are perpendicular lines. So when we say perpendicular lines, these are two lines that intersect to form right angles. So in here, we have line A and line C. So line A is perpendicular to line C. The symbol for perpendicularity is an inverted capital letter T. Next, from the figure on perpendicular lines, we have this one. An angle with a square or rectangle figure on the vertex. That angle is called, very good, it's a right angle. So it's an angle whose measure is exactly 90 degrees. Next, we have here an acute angle because it's less than 90 degrees. If we're going to copy this angle to form another angle and name that copy of the angle as angle B, then these two angles formed now are congruent angles. So when we say congruent angles, these are angles with equal measurement because we just copied the first angle. Now, don't get confused when we say congruent and when we say equal. We use congruent if we are pertaining to the figure itself. So if we are comparing angle B and angle A, then we must use congruent. So I say angle A is congruent to angle B. But if we are dealing with their measurement, then we use equal sign. So measurement of angle A is equal to the measurement of angle B. So take note, the measurement of an angle in symbols is a small letter m written before the name of the angle. So that's all about congruent angles. If we have what we call congruent angles, we also have congruent segments. So we have here a segment and a copy of that given segment. These are called congruent segments. So by definition, these are segments with equal measurement. So if we name the first line as segment AB and the second one as segment CD, then we can say that segment AB is congruent to segment CD. Congruent because we are pertaining to the segments. And with regards to their measurement, then we say AB is equal to CD, or the measurement of AB is equal to measurement of CD. For the measurement, you can use the two endpoints or the two capital letters that will already mean that we are pertaining to the measurement of that segment. Or in some books, they use the small letter m followed by segment AB. Next, we have here two angles, angle LVO and angle LVE. Note that these two angles here has a common ray. That's ray VL, which makes them adjacent or consecutive angles. And the two non-common rays form a straight line. That's why they form a linear pair. So when we say linear pair, it's two adjacent or consecutive angles which measures 180 degrees. Note that a straight angle or a straight line measures 180 degrees. So in here, the measurement of angle LVO plus the measurement of angle LVE is equal to 180 degrees. So if the measurement of angle LVE is 77 degrees, then what is the measurement of angle LVO? Very good. It's 103 degrees. So that if we add the measurement of those two angles, the sum is equal to 180 degrees. Now, using the same figure, aside from forming a linear pair, the two angles are also called supplementary angles. When we say supplementary angles, these are two angles whose sum is 180 degrees. But this time, it's not necessary that those two angles are consecutive or adjacent. They can separate as long as their sum is equal to 180 degrees. Next, we have here angle MAT, which is a right angle. And on that angle is a ray. Dividing it into two, we have ray AH. So since it's a right angle, then those two parts, when we add them, that must be equal to 90 degrees. So in symbols, we have measurement of angle MAH plus the measure of angle HAT is equal to 90 degrees. We call them complementary angles. So these are two angles whose sum is 90 degrees. A while back for supplementary, the sum is 180 degrees. So if the measure of angle HAT is 63 degrees, then what is the measurement of angle MAH? Very good. It's 27 degrees. So we just have to subtract 90 by 63 degrees. Next, we have here two intersecting lines. Note that when two lines intersect, we form four angles with two pairs of opposite angles. These pairs of angles are called vertical angles. These pairs of angles are called vertical angles. These are opposite angles formed by two intersecting lines and facing opposite directions. So in here, what are the two pairs of vertical angles? Very good. We have angle 1 and angle 3 and angle 2 and angle 4. Next, we have here an angle measuring more than 90 degrees. It's an obtuse angle. Now, if a line, let's say ray AH, divides the angle into two equal parts, then we can say that angle MAH now is congruent to angle HAT. Those two small angles formed now are congruent. So if the measure of angle HAT is 50 degrees, then the measure of angle MAH should also be equal to 50 degrees. And we now call that ray that divides the angle into two equal parts the angle bisector. Next, we have here a segment QT. At the center of the segment is a point named point U. And that point U divides the segment into two equal parts. So we now have segment QU is congruent to segment UT. So if segment UT measures 7 units, Then segment QU also measures 7 units. That point U now that divides the line into two equal parts is called the midpoint of the line. So those are the defined terms in geometry. Let's now have the third component of the mathematical system in geometry, which is the postulates. These are statements that are considered true without proof or validation. Like what we have said last time on our discussion about proofs, postulates are used to prove or justify statements. We have here 2 points, points Q and T. Now, given this point Q, we can draw a line to point T. So, given the 2 points, we now have a line. So, the first postulate is a line can be drawn from a point to any point. Another postulate is a circle may be described with any center and radius. So say for example, we have here a circle with center at point C and a radius to point T, which is on the circumference of the circle. Then that radius and center describes the circle, or can be used to describe the circle. Next, we have here a right angle, angle A, and another right angle, which is a smaller one, named angle B, and another angle, angle C. Take note that right angles measure 90 degrees. So that means all these three angles are congruent because they have equal measurement. So the next postulate is all right angles are equal. Next, through a given external point not on a line, there can be drawn only one line parallel to the given line. So say for example, we have here line M in a point which is not on the line. We can draw only one line that passes through that point, which is parallel to the given line. And let's name it line N. So with this, M is parallel to N. Another one. A plane contains at least three non-collinear points. So if we have point A and point D, and connecting those 2 points, take note, we only formed a line. It's not yet a plane. Now, if we have a third point, but it's on the line, meaning that point is collinear to points A and B, then again, we cannot form a plane. Because take note, it must have at least three non-collinear points. When we say non-collinear, when you draw a line, they should not be on the same line. So, like this, say for example, point C. If we draw a line, it will not pass through the other point. So, connecting those 3 points, we now form a plane. So, at least three non-collinear points, we had made a plane. But you can also use three or more points, three or more non-collinear points, like this one. We have point D. So we have another plane, A, B, C, D. Next, if two lines intersect, then they intersect at a point. So we have here two intersecting lines, line M and line and they intersect in a single point, and that point of intersection is named point B. So there is only one intersection, which is a point. Another postulate is described by this figure. So we have here angle MAT with ray AH on that angle, which divides the angle into two parts. So since those two smaller angles are the parts of the larger angle, then we can say that if we add those two smaller angles, then it is equal to the measure of the larger or the whole angle. That is by angle addition postulate. In symbols, we have here the measuring of angle MAH plus the measurement of angle HAT is equal to the measurement of angle MAT, which is taken from the fact that the whole is equal to the sum of its parts. Next, we have here the two angles, angle LVO and angle LVE. What's the relationship of those two angles again? Very good. They are both form a linear pair and they are supplementary. So here we have the supplement postulate or the linear pair postulate, which states that if two angles form a linear pair, then they are supplementary. But it doesn't mean that supplementary angles always form a linear pair, because all angles that form a linear pair are supplementary, but not all supplementary angles form a linear pair. Next, we have the last component of a mathematical system in geometry. We have theorems. Theorems are statements that are proven to be true using postulates, definitions, other established theorems, and logic. So unlike postulates, theorems need to be proven. They are only accepted after being proven other using postulates, definitions, or other valid statements. We have here again two intersecting lines, line M and line N. And as what we have already stated, four angles are formed. So our first theorem is vertical angles theorem, which states that vertical angles are congruent. So if they are vertical angles, then they are congruent. So in here, since we have angle 1 and angle 3, which are vertical angles, then angle 1 is congruent to angle 3. Also, we have angle 4 is congruent to angle 2. Another theorem is called the supplement theorem, which states that the supplement of congruent angles are congruent. So given two congruent angles, let's say angle A is congruent to angle C, and each angle has their own supplement. Let's say angle A is supplementary to angle B and angle C is supplementary to angle D, then we can say that angle B is congruent to angle D, or the supplement of those two congruent angles, angle A and angle C, are also congruent. If we have supplement theorem, we also have what we call the complement theorem, which states that complement of congruent angles are congruent. So given two congruent angles, angle A is congruent to angle C, and angle A is congruent and angle A is complementary to another angle, which is angle B, And angle C is also complementary to another angle, which is angle D, then we can say that this complement of those two congruent angles are also congruent. So we have angle B is congruent to angle D. There are other theorems and postulates aside from what we have discussed, but but we will just stop on this for now. That ends our discussion. But before we end this video, always remember that a mathematical system in geometry is composed of four. First, we have the undefined terms, which includes the point, line, and plane. And second, we have the defined terms, which includes the segment, the angle, parallel lines, perpendicular lines, right angles, congruent segments, linear pairs, complementary angles, vertical angles, angle bisector, and midpoint. Then we also have the third component, the postulates. We have a line can be drawn from a point to any point. A circle may be described with any center and radius. All right angles are equal. Through a given external point not on a line, there can be drawn only one line parallel to a given line. A plane contains at least three non-collinear points. If two lines intersect, then they intersect at a point. We also have the angle addition postulate and the supplement postulate or the linear pair postulate. And last component is theorems, which includes the vertical angles theorem and of course the supplement and the complement theorems. That's all. I hope you learned a lot from this video. Thank you for watching, and a special thanks to Miss Teresa J. Basilio, the developer of the module titled Geometry as a Mathematical System, which is the main source of the content of our presentation. Goodbye!